Welcome to EG channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I will discuss about the mesh analysis, a very important reduction technique which is useful to find out the required response in the given network problem. First of all, what is mean by a mesh? Mesh is nothing but simply it is a loop or a closed path in the circuit, that is called a mesh. And mesh analysis you can apply for only planar networks. What is the planar network? The circuit in which there is no any crossover, that is the planar network. Mesh analysis is not applicable to the non-planar. Hence, the mesh analysis can be depends on Kirchhoff's voltage law. By using Kirchhoff's voltage law, that is KVL, you can analyze the loops equations. And number of loops is equal to the number of loops is equal to number of mesh currents. By applying KVL to every loop, then you can find out the corresponding loop current in the given circuit. For example, the mesh analysis you can analyze by taking the following example. Here, find out the mesh currents in the given circuit or find out the loop currents in the given circuit. First of all, in the given problem, you must analyze how many loops are there. That is, in this circuit, we have two loops are there. First loop and this is second loop. That is, you can find out two loops. Hence, you can, after identifying number of loops, then you can assign the loop currents. For first loop, we can assign the loop current is I1. For second loop, you can assign the loop current is I2. You can take the current direction either in clockwise or in anti-clockwise. Any direction you will take. If clockwise direction you will have negative values, then it will simply taken as the anti-clockwise direction. Then here, after assigning the current directions, then you can simply assign the signs for elements in each loop according to the current directions. Always the current passing through the elements is plus 2 minus. Okay. In the first loop, I1 is passing through 5 ohms plus 2 minus. Again 2 ohms from plus 2 minus. Similarly, in second loop, I2 is passing through element through 10 plus 2 minus. Again 2 ohms plus 2 minus here. Here, the middle element 2 ohms is called the mutual element. That means that 2 ohms can be belonging to the two loops, first loop and second loop. That's why both currents I1 and I2 are passing through 2 ohms. That is called the mutual element. Remaining elements 5 ohms and 10 ohms are called the self elements. 5 ohms belong to the only first loop and 10 belongs to the only second loop. But 2 ohms belongs to the both loops, loop 1 and loop 2. That's why 2 ohms is called as the mutual element. Hence, after assigning signs and current directions, then simply you can apply KVL to each loop. Then you must write down the step is apply KVL to first loop or loop 1. Then assign here for 10 voltage source, the I1 is passing from minus to plus. That's why positive 10. Again, for I1 is passing through element 5 ohms from plus to minus. That's why the drop is minus I1. Simply for 2 ohms also plus to minus. That's why minus 2. Here 2 ohms is belongs to the two loops. That's why the current is I1 minus I2 because here we are writing the equation for first loop, then taken as I1 is greater than. We don't know the values of I1, I2. That's why you are writing whichever loop is writing, that current is taken as higher value. That's why here we are writing equation for first loop. That's why I1 is larger than I2. Then the drop is I1 minus I2 into 2. Then simplify the equation here. That is 5I1 plus 2I1 minus 2I2 equal to 10. Then simplify the equation here. 5 plus 2, that is 7I1 minus 2I2 equal to 10. If you know very well the KVL equation, then directly write down by applying KVL to the loop, that is loop 1 equation. The loop 1 equation you can write down directly. That is here, observe here, the loop 1 current is passing, I1 is passing through 5 and through 2 also. That's why here we can analyze I1 is passing 5 ohms and 2 ohms, nothing but like a series connection. That is total value is 7. Then 7 into I1. That is the 7 into I1 drop here. Similarly, the 2 is the belong to other loop also, second loop. Then other loop drop is 2 into I2. That's why here observe the current direction. Both are reverse. That's why you can take negative value, that is minus 2 I2. That equal to source value. Before equal to, you can write down the sum of voltage drops across the resistances. After the equal to, you can write down the sum of voltage sources in the corresponding loop. In first loop, we have only 10 voltage source, but I1 is passing from minus to plus, that is lower to higher potential. That's why after you could write down the positive 10. Okay. In the same way, we have to write down the loop equation for second loop also. Then simply the step is apply KVL apply KVL to loop 2. Okay. For loop 2 also, for second, the 2 ohms is mutual element, and here we are writing the loop equation for second loop. That's why the drop taken as I2 minus I1. Simply here 2 into I2 minus I1, but current passing from through element is plus 2 minus. That's why taken as negative. And also other element is 10. Then the drop also is here through 10, only I2 is passing. That's why minus 10 into I2. And here the second loop consists of the other source voltage value, that is 50. And also the direction is from plus to minus. That's why here taken as also the voltage source value is minus 50. Then equal to 0. Sum of voltage values in the corresponding loop is 0. Then you can simplify that equation here, that is 12 I2 minus 2 I1 equal to minus 50. That is taken as equation 2. Then you can solve I1 and I2. You can solve by using Cramer's rules also. You can solve the equations. Then or by using calculator, you can simply find out the values of both group equations. Then the value of I1 you will get here 0.25 amperes, and I2 is taken as minus 4.125 amperes. Okay, these are the corresponding loop currents I1 and I2. In this way, you can find out the mesh analysis and find and apply KVL to every loop, then find out the loop currents. Okay, remember here the main point is by applying KVL, we can find out the loop currents, After finding the loop currents, you have to find out the voltage drops across each element and also the power loss in each element after finding the corresponding loop currents value. And another important topic in mesh analysis is nothing but here, that is super mesh analysis. Very, very important topic. There is compulsory problem on super mesh in university examinations also. What is mean by super mesh? That is whenever a current source, here this is the current source 2 amperes here, by taking one example here, whenever a current source belongs to the two loops, then that is called the super mesh analysis. You can apply the method of super mesh analysis when current source is a mutual element. That is, the current source belongs to the two loops. Then you can apply super mesh analysis. Remember here. Then in this, for example, take the problem, find the current through 5 ohms. Then by applying a super mesh analysis. Why? Because in this problem, 2 amperes is belonging to the two loops, second loop and third loop. Here, how many loops are there? In this problem, we have three loops. This is first loop, this is second loop, for example, taking, and this is third loop. Okay. Then, what is the first assignment? You can assign the current direction I1 and second loop I2 and third loop I3. Here you can find out the loop currents I1, I2, I3. And what is the super mesh here? You can write down single mesh loop equation by combining both second loop and third loop. Why? Because the current source belongs to the second and third loop. Wherever the source belongs to two loops, you can write down single equation by combining at a time both loop equations. Okay, here I'm showing here the write down direct equation, apply KVL to the first loop. That is, apply KVL to loop 1. I am writing equation directly. That is, the loop current I1 is passing through 10 and 15. Then the total drop is 15 I1. Similarly, 10 ohms belong to second loop also. Then I1 and I2 both are passing through 10 in reverse direction. That's why taken as minus 10 into I2, other loop voltage drop. That equal to, in first loop we have the source value 50, then current is passing from minus to plus. That's why taken as positive 50. Then this is first equation. Similarly, apply KVL, nothing but you can apply KVL to super mesh. Why we call it super mesh? That is 2 ampere source is belonging to the both loops here. Then simply apply here. For second loop, 10 volts belongs to the two loops. That's why minus 2, then I2 minus I1, and another loop current is and 2 ohms passing to only single loop, that is minus 2 I2. And for third loop, you can combine both equations. These two are the drops for second loop, and simply you can combine third loop also. For third loop, we have the two elements 1 and 5. That is, for 1, what is the drop? Minus I3. And for 5 ohms, what is the drop? 5 into minus 5 into I3 minus I1 equal to 0. Then this is the second equation. You can arrange the equations here. Then total loop currents here. minus here, okay, simply wrong. Here not 2 ohms, we have 10 ohms here. That's why we take it as minus 10, I2 minus I1. Not 2 ohms even. 10 ohms belongs to the both loops. That's why 10 ohms is given. You can simplify the above equation here. That means minus 10 into I1 plus 10 plus 2, that is 12 into I2, and also we have 5 also is there. Then we have minus 15 is there. 10 plus 5, 15, and 12 I2, again 5 plus 1, 6, then 6 into I3 equal to 0. That is second loop equation. Okay. Here, very important point is you can write down the mesh equation by combining two loops. Wherever the current source is belong to two loops, then both equations you can write down the combined. Then we call the super mesh equation. Then after that, after writing super mesh equation, then write down the current source equation. That is current source, you can take it as I2 minus I3 equal to 2 amperes. That is why, because 2 amperes belongs to the two loops, second loop and third loop. What is second loop current? I2. Third loop current I3. Then observe the direction of I2, I3 with 2 amperes. We have the same direction of I2. That's why taken as positive I2. Then I2 minus I3 equal to 2 amperes. Then we can solve the three equations 1, 2, 3. Then you will get the value of I1 is nothing but 19.99 amperes, approximately 20 amperes, and the value of I2 you will get 17.33 amperes, and the value of I3 you will get 15.33. Okay, but here our aim is to find out the current passing through 5 ohms. That is, that current I am taken as I5, current passing through 5 ohms. Then the current 5 is belong to the first loop and third loop. Then current is I1 minus I3 or I3 minus I1. But here I1 is large value. That's why I'm taken as I1 minus I3. That is 19.99 minus 15.33. Then the value is 4.66 amperes. Okay, in this way you can find out the super mesh analysis. Okay, the important point is you can apply mesh analysis where the current source is belonging to the two loops. Then write down single loop equation by combining two loops. That equation is called the super mesh equation. Subscribe our channel and share to your friends also.